And we're going to go ahead and get started. Folks are still rolling in, but without further delay, I'd like to introduce you to our webinar for this month. Today, we're featuring John Pettis from Wikoff Color. Graphic Arts Alliance has had a relationship with Wikoff for many years, and we're excited to have them here today to give us a presentation on color management. And John is the Director of Corporate Sales and Marketing. So John, go ahead and take it over. They are yours. And if anyone does have any questions, please feel free to put those in the chat. And we will also have Q&A at the end. So it's all you, John. Thank you again.
All right. Well, thank you, Wendy. I appreciate the introduction. And hello to everybody with Graphic Arts Alliance. As Wendy mentioned, we have been a supplier partner for you all for many years, and also Braden Sutton Ink Company, which is now part of Wikoff Color. So we appreciate all of your business and have enjoyed our business relationship. I will give a really small background on Wikoff Color and myself, just to let you know that I am competent enough to give this presentation. But if we get too deep into the Q&A, I'll probably direct you to our technical director after this. So for those of you that are not aware of who Wikoff Color is, we are an ink and coating manufacturer, and our value proposition is to be very close to our customer base so that we can manufacture the products that our local customers need when they need it and be press side when the need arises. And that, when we say our mission is to be your experts, that's just that. We want to be close by, and we want to provide all of the services and high quality products that you need to operate your business. Printing is still a very challenging industry to be in. That's why we get up and what draws us to it every day. And Wikoff just wants to be that supplier partner for you all and recognize the challenges that you have and help you overcome those. For those of you that don't know, we are an employee-owned company, which means Andrea and I that are on this call, we own stock in the company. It just gives us a little bit of invested interest in the success of Wikoff. And this is a map of our U.S. locations. We're a global ink manufacturer. We're predominantly in North America, but as you can tell, we have a lot of small manufacturing locations. And as I was mentioning earlier, these are intended to be close by to our customer base so that we can manufacture blended colors locally. And we do serve several different markets. Commercial is our main focus of today's conversation. Some of you may be entering some other packaging spaces like folding carton and label. We certainly provide those markets as well and have a lot of expertise in those areas. One interesting business segment that I have that I tell my friends about over dinner that have no clue what it is printing is or what I do for a living. We make the inks for the scratch-off lottery tickets, which is a really cool business for us to be in, and also an interesting fact. It's a big piece of business for us, a very technically demanding business, but it's a fun one to be part of. And then I'll stop here with the company intro, but just the products that we make as it relates to your business. For flexography and rotogravure, we make water-based, energy cure, solvent-based inks. And for lithography, we make oil-based, UV cure, HUV and LED, low energy cure technologies, and EB cure. We also manufacture a full line of coatings, and we have press room products to help support your needs as well. So that's color management devices, which we'll talk about today, chemicals like fountain solutions and other press room chemicals, blankets, rollers. We have photopolymer plates for the flexo side of the business. So we've got a wide variety of products there. Any questions in regards to Wikoff before I move into the next segment here? Okay. So we'll get into the color management side of the presentation today. And where I like to start is our eyeballs and a presentation that we call the I factor. But it's essentially explaining to everybody how terrible our eyes are for colorimetric devices. So there are some inherent problems with using our eyes as spectrophotometry devices. So we have retinal fatigue, that if you have brief exposure to strong colors, it continues to remain after looking at an image, and you need considerable rest for your eye to recover. A big example of that would be when you look at the sun and that big brightness, then you move your eyes and you can still see the dot going around. Or when I move off of this big white screen, you'll see a white block. Those are some examples. This is a good one. If you'll stare at this white dot for the next 30 seconds.
Okay, so stare at the center dot for 30 seconds.
Wendy, is that volume coming across?
Yes, it is.
Okay.
What's so that's right. And
All right. Did everybody see the red, white, and blue come across?
Oh, no. I didn't.
No? Okay, it might be helpful if you either turn up the brightness on your computer monitor or lower the lights in your offices. We'll do another one with the Canadian flag here, and we'll go 30 seconds. If you stare at the red dot in the middle for the next 30 seconds. And keep your eyes focused on that center red dot. All right, does everybody still see the maple leaf in the center?
Yep.
The Canadian flag?
Yeah, and the green.
So that's what we say with retinal fatigue. The colors that you were looking at will still leave a lasting image. So when you're press side and trying to look at color and staring at colors one after the other in long periods, your eyes are going to become fatigued. It'll become more difficult in recognizing color the longer you try to do that. Here's one last one. We'll do a quick one here. If you'll just stare at the young woman's nose for the next 30 seconds. All right, so you should have seen the inverse of the image. You should have seen the young woman come up in full color.
Wow, that's amazing.
Yeah. All right, so we're going to get into some other fun areas of the eye factor where our eyes and brains play tricks on us. This is going to be a participative, engaging segment here, so I'm going to need some feedback from you all as we go through this. But this is a shadow illusion. So does anybody think that the squares marked A and B are the same color?
No.
Yeah, the words here kind of give it away. I should have hidden those before we got started here. But even knowing that these are the same color, is anybody skeptical that that's true? Me looking here now, I still, after all these years, say those cannot be the same color. But if we shift the screen like that, you can tell they are the same color. And same here. If you look at these dots independent, the orange square on the shaded side of the cube looks much lighter than the square on the top of the cube and the one laying down. But once we remove the color around it, you can tell that those are the same color. So this is showing where background effects can really impact us in how we're able to judge color. So we should always be aware of our field of view, and our fovea sees the greatest level of detail, but it's still affected by the rest of our eye. So do these grays look the same or different to everyone?
Different.
Different. Does the one on the left-hand side look darker?
Mm-hmm.
That's how it looks to me.
Yeah.
Yeah. Same gray.
Oh, wow. Perspective.
Yeah. All right. This one to me shows an even bigger contrast. The top right looks much lighter to me. Is that the same for you all?
Yeah.
Do the oranges look different?
Mm-hmm. Yep.
Yeah. So same thing there, all the exact same oranges. And as our industry is one of tangible print, it's more pronounced with printed sheets than it can be on an illuminated screen like we're looking at today. All right, here's a really good one. Anybody want to challenge me when I say that these blues are the same? Do they look the same? Okay, I like when it's more in person. I can see everybody nodding and saying no.
They look the same to me. I think the blues
Oh,
are the
they
same.
look the same to you. Okay, the one on the left side for me looks a lot darker.
Okay.
Right.
Yeah.
Yeah, it does look
Okay, I hear a couple yeses there. Same blue. So again, all that background color is really influential in how we perceive color. So when you're taking sheets off the end of your press and you're trying to judge color, it can really impact how you're seeing it. Or when you've got a customer in and they're doing a press okay, that design of the print can really impact the color that they think they're going to get. And that's where this color management conversation we're having comes into big play. So we have software and hardware that helps us read color. And that's because our eyes are such poor judges of color. Here's another interesting one. I just want somebody to try to peg down where the black dot is and just keep it in the same place. Anybody successful on that?
No.
Not at all.
Yeah, it's so strange. I see the black dot moving everywhere, and there's a lot of black dots, but it's all just an optical illusion here. So I'm going to warn you all on this one. The psychiatrists tell us that the more this image is moving, the more stress you have. So if anybody has this where it's moving a lot, that means you're really stressed out. Anybody like me where this thing's just moving like crazy?
Oh, no.
Yeah. Andrea, how bad is it moving for you right now?
Pretty bad.
Yeah, I always say that joke, and I don't know if it's stress or not, but the image is a still image, and you can tell that by concentrating on any one of these circular patterns. But then all of the patterns around it, because of the image's design, moves, and it's just an optical illusion. So the next thing that we'll get into is how poor our color memory is. And again, this is one where actual tangible print shows it better, but hopefully we can get the message across how poor our color memory is by looking at the screen here. But to look at color and remember, we must look at the objects, two objects simultaneously in order to fully judge their differences. And these next slides are going to show the example. So everybody look at this pink and try to remember the color. And I'm going to ask for some feedback here on the next slide, okay? Everybody got the color memorized?
Yep.
All right, so give me some shout outs here. Tell me what letter the colors are. What pink do you think this is?
Should be around H.
H? Anybody else?
I or G.
Okay.
We've got some comments in the chat. We're I, H, I, Z.
Okay.
All right.
Good. All right. E. So we go back here and go E. I don't think we had any E's.
I don't think so.
Yeah, so he's not too far off, but we were definitely going into the bluer side of these pinks from our color memory. And I was with you. I can never remember which one it is when I present this. I was thinking H as well. All right, so everybody try and remember the red. And we put a neutral gray background on here because that's the color our eyes can discern the most. That's also a major theory in color management that we can get into in a bit. So does everybody have the red memorized? Okay, which one?
6.
6. I'm going to say 5. Anybody else? I work with too many Georgia fans, so this is a painful color for me to see right now. They're becoming quite obnoxious with how good their football team is. All right, 5 it was. All right, so some interesting statistics on color blindness and also part of what you should consider when hiring people for your press rooms. 1 in every 13 males suffers from a red-green color blindness, compared to every 1 in 300 females. So ladies, congratulations. That's just one more thing that you're better than men at. When I present this in an audience, I want to tell people on these next slides, hey, do not raise your hand if you can't see this. It's fine. Don't tell everybody. But some people volunteer themselves and say, oh, I can't see this. But I will ask, what number is shown here?
$42.
42.
Yeah, there we go. 42. All right, so if you can't see the 42, you may be somewhat colorblind, just if you've never gone through the test. So this is the image that it would look more like for somebody that is colorblind. They have a lot of trouble discerning between the reds and the greens. So getting into some color management best practices. We are always talking about standard lighting conditions for this very reason. The D50, 5,000 Kelvin is the temperature for we as ink manufacturers like to use that so that we can be consistent when viewing color. One thing, if you've ever heard of metamerism, we can formulate colors, and based on the pigment selection, it can look completely different from a D65 to the left-hand image to the right-hand image. And it can flip almost and look like a completely different color. These conditions are also why if you'll go into a Lowe's or a Home Depot or a home improvement store and look at paint swatches, that you have these different light conditions. It's because people will go buy paint at a Lowe's that's got 5,000 degree lighting in it, and it'll look this particular type of tan that they like. And then they go home to a much warmer lighting conditions and it looks way brown and way yellow. And people get upset and bring the paint back. That's so that people can see the color under different lighting conditions. So this is a fun one. Let's all read together you need to say the color, not the word. So the first top left would be green. So it'd be green, red, blue. It's going to be tough for me to get volunteers since we're virtual.
Yellow,
All right, it was on,
blue, black.
should
Yeah.
be all set now. It was on a layer.
Red, blue,
I
green.
didn't remember what it was, and I turned it off. So I'm like, I was clicking it on and off, but I didn't see anything.
Black, red, yellow. It's really hard.
Yeah.
Anyone else?
I'll try it. Green, blue, black.
Oh, you're on the next to last line. All right. Okay. Yeah. So this is showing us the difference in the red brain, the left brain and the right brain conflict. But if we were to give this test at different grade levels, can anybody guess which grade level would pass?
Second, first grade.
Usually the kindergartners have no problem because they can't read yet. So they just see the color for what it is. They can't read the colors just yet. So they'll blow through this test with no problems. With the rest of us, our right brains, or excuse me, our left brains start to kick in and start reading it versus just seeing the color. All right, so we're coming to the end of the I factor here. And again, this was just a fun example to show us that our eyes and our brains are poor color measurement devices. And it really is a nice way to open up into the color management conversation. But as a reminder, some things that we've discussed here are retinal fatigue, how background affects the colors that we see. We have very poor color memory. Color blindness is more common than you probably were aware of, and that lighting conditions are a big impact on color. All right, so any questions about our eyes and our brains as colorimetric devices before we move into the next piece is getting more into the hue and chroma and elements of color management. All right. So I'm going to pull up a video that a young woman from Clemson University has created for us. And this is going to go through some basics of color management. And then we can end with current color management systems that you all are probably adopting into your press rooms. And then we can end here today with the Q&A. So give me 1 second. I'll get this video going.
Color is light, which is a form of energy that is on the visible light spectrum. In the 17th century, Sir Isaac Newton established that clear white light was composed of 7 visible colors through a series of experiments with sunlight and prisms. These colors are found in the visible light spectrum, which is just a tiny part of the electromagnetic spectrum. The visible light spectrum is generally considered 400 to 700 nanometers. Colors on the visible light spectrum come in 3 dimensions: hue, chroma, and lightness. Hue is the first dimension of color. Let's imagine taking that band of visible light from the electromagnetic spectrum and bending it to form a circle. This will create a hue circle, which looks like a color wheel. The hue angle is where on the hue circle a particular hue lies. See how the hue angle for point B is higher than point A? If we translate that into the hue circle, we will see that A is bluer than B. For example, where on the hue circle would this car go? It will go right here in the red spot because it has a red hue. The second dimension of color is chroma. This is how clean or dirty a color is, and this is shown by how close or far away a point is from the center of the color wheel. This vividness is commonly known as saturation or chromaticity. See how the car on the left has a higher saturation than the car on the right? This is because the car on the left has more chroma than the car on the right. The third dimension of color is lightness. Imagine this color wheel is a sphere, and the higher up on the sphere, the more lightness color will have. Here's a great example of all three dimensions shown in a sphere. See how the lightness goes up as you reach the top of the sphere? The chroma increases as you get closer to the outside of the sphere, and the hue changes all the way around the sphere. What is needed to see color? This is a three-part system. First, you need a light source, so that light can be reflected as colors. There needs to be an object to interact with the light, and there needs to be an observer of some kind, whether that be a camera or your eyes. What creates color? This depends on the amount and type of light reflected and absorbed by the object. Objects do not make light, they absorb it. And what they do not absorb is reflected. This apple in this picture looks green because that's the color of the light it reflects. Light comes in a range of temperatures. Like a match flame would look a lot warmer than the northern lights, just like a graphic arts monitor would look a lot cooler than cool white fluorescent lights. Spectrophotometer defines color based on 3 dimensions, like longitude, latitude, and depth. A spectrophotometer shoots light onto an object and measures the amount of reflectance at intervals throughout the visible spectrum. Once the reading is finished, the spectrum receives the data and can be read on the spectro or a computer if it's connected. Purple 512 is a darker color. Therefore, the total amount of light reflected is lower than the previous green example. The lower reflectance is depicted by no reflectance peaks above 30. Spectrophotometer calculates the LABCH values from the reflectance values. The LA, B, C, and H values are all indicators of different aspects of a color based on the 3-dimensional plane. Back to lightness, which is based on the vertical layers of a color. The same color can be darker or lighter depending on how high or low its L value is. Each layer on the lightness chart gets lighter and lighter as the levels go up. The A and B values define the hue of the color, and these values can be positive or negative depending on the hue. Each direction is representative of yellow, red, blue, and green. A good way to remember this is by remembering the fruit. Positive B is banana because it's yellow. Remember, B, yellow banana. Positive A is red apple. Negative B is blueberry. So now we have 2 B values. Positive is yellow banana, and negative is blueberry. Finally, we have negative A for green apple. So positive A is red apple, and negative A is green apple. Let's take a look at lightness, and we're going to use 40 for the base value. See how as the value goes lower, it gets darker. As the L value gets higher, it gets lighter. The higher the L value is, the lighter a color is. Let's take that information and translate it to algebraic plotting. If you have an x value of 60 and a y value of 40, the point you're trying to find would be right here where the dot is shown on this graph. Finding color based on a and b values is exactly the same. So let's show this as an example. If the a value is 50 and the b value is 20, it would land our dot right here in this red-orange color. Remember how we said that hue is based on angles? Here we can see that it's very easy to find the color if we know the hue angle, since circles have 360 degrees, with 0 starting where the red or positive a value is. Chroma, the second dimension of color, is how clean or dirty a color is, or how close or far away a color is from the center of the circle. But how do we get this value? So our L value has already been given to us, along with our A and B values. The H value, or hue, is the angle from which the point is on the circle. The only value that isn't so obvious is chroma. Chroma is calculated by taking the square root of a squared plus b squared. So we can see here that our chroma value is 53.85. LAB and LCH help define a color standard in any subsequent sample or trail. Delta E tolerances make it much easier to determine if a sample is acceptable. Multiple DE tolerance methods have been used throughout the years. DE76 was the first method and is still used today. DE2000 is a much improved DE calculation that is gaining rapid adoption within the graphic arts industry. DE tolerances allow us to quickly determine whether a sample is acceptable. A DE76 tolerance of 2 or less is considered a match by 75% of general population. DE76 simply calculates the differences of LAB values and does not consider chroma or hue angle. DE2000 calculates the differences in LAB, C, and hue angle. The more robust calculation of color differences enable a much higher level of agreement that samples match the standard. 95% of the general population sees DE2000 of less than 2 as an acceptable match. Let's take a look at DE2000 CMC tolerance. Notice the sizing of the ellipsoids in the color space? As the hue changes more drastically, the ellipsoids shrink to represent the color change. The ellipsoids near the edge of the color space appear much larger than those in the center. Another important thing about spectrophotometry is the illuminant and observer angle. The current industry standard is fluorescent lighting, so this is the type of lighting the standard requires you to use, and the observer angle is 2 degrees. This is how much area you're allowing into the observer. See in the graphic how much more area is covered with just an 8-degree increase from the standard. Here are some more light temperatures. A standard incandescent light is so much lower than an industrial STD.
All right, well, I hope that was educational for everybody. So I'm going to pull the PowerPoints back up and go to the slide that has some current color management standards like G7. Get here. All right, so I think this is a pretty good slide that we can have as a backdrop as we get into our Q&A. What questions does everybody have for us?
So at this point, if you want to go ahead and unmute, and ask your question, or you can put a question in the chat. And you know, while everyone's thinking about a question, I actually am curious, John, when you're working with customers and you know, they might be having some difficulties with color matching. Do you have specific recommendations for them, or if you know if they're having problems with how the press is running a certain color? What are some of the recommendations that you're making to your customers to ensure that they're getting the best, you know, the best color with, you know, the products you have?
Sure, I think we could address that in several different ways. If there's color inconsistency from job to job, then some of these color management things that we have on the left-hand side of the screen here are really good. So G7, when we had in the video, there was the color gamut at the end, and the ellipticals shrank as you got closer to the center. And that has to do with neutral gray. So the center of that circle was neutral gray, and that's where those ellipses were their smallest. And that's the premise of G7 color management. You're calibrating all of your equipment, to your proofing equipment, to multiple presses on site, all to the same neutral gray. And that is so that you can have color consistency across your 4-color process printing. If you are talking about line colors or PMS colors, then you can use spectrophotometry to help make sure you match the same color standard every time. And that becomes very important where you have, you're trying to match the same color, but have different shades of substrate. So we all should be aware of having a yellow shade or a blue shade substrate. But if the printer wants the same red on both shades of that, it's actually going to be a different color match for us. So we would use the Spectro and our eyes, but mostly the Spectro to tell us how good the color match is between those 2 different shades of stock. So two completely different finished inks then.
Yeah, no, that's really helpful. Does anyone else have any questions about this presentation, about a specific color management principles or tips that might be useful if you have something going on that you've noticed in your own press room that maybe you haven't figured out a solution for? Certainly, now's a good time to pick John's brain. And while we're thinking about all of the things that you presented today, I just wanted to remind everyone that we do have a program with Wikoff Color. We have the ink program that we have is a rebate-based program. And John, can you tell us a little bit about typically if someone were to call you up as a potential new customer, what process do you go through to kind of test the inks with them and potentially get them set up as a new customer?
Sure. So we would certainly get a meeting together with our local sales rep. That would be your main point of contact. And we would ask a series of questions about what your needs are and expectations. Try to understand what problems you may be having at the moment, what opportunities there are for us to come help you and fix any challenges that you're having press side. One area that we have earned a lot of new business is GMI expectations, where your customer base will come in and say, you have to meet GMI standards. And you might be asking, how do we do that? What do we do? That's an area that we can come help. So whether it's color management or just inks not performing very well in your press room, we would ask a series of questions and figure out exactly what you need and start problem solving.
Great, thank you. It looks like in that time we've got 2 questions rolling.
Okay.
Brandon Johnson is asking, how often should rollers be replaced to maintain color consistency?
It's all about preventative maintenance. I hesitate to give an answer on how often you should do a full roller replacement. But I would be doing your preventative maintenance, best case on a weekly basis. But if you're seeing color inconsistency, make sure you're looking into your roller, your different are they picking up calcium, or what issues might be driving? But preventative maintenance is going to be your best bet.
Great, thank you. And another from Paul DeSantis at ANRO. What are the most common color reading devices?
The one we see the most now is the X-Rite Exact. It's a pretty robust piece of software and hardware. The other industry standard is a Teshcon device. Teshcon presents itself much more in Europe, so we'll see a lot more X-Rite here in the States.
Excellent.
So
Great,
and I can go a little bit more. So
Yeah,
all we really hear about nowadays is spectrophotometry, but densitometers are still around, the old 630s and things like that. So measuring densities is better than doing nothing, particularly on 4-color process. But when it comes to measuring spot colors or line colors, spectrophotometry is really the way to go.
excellent. Thank you so much. Any other last questions before we wrap up for the day? Wonderful. Great questions from everyone. Great participation. I love the whole eye fatigue exercises. That was really eye-opening for me personally. Really great way to illustrate that we can't really trust what we're seeing on paper to know that the colors are matching up. So thank you again, John from Wikoff Color, for coming out and giving a presentation. We're going to be recording this, and so this will be up for all of our members to see. And certainly all of the members, if you have any questions, don't hesitate to contact John directly. I will put all this information in our upcoming newsletter. John, thank you so much again. Have a wonderful weekend, everyone.
Thanks, everybody. Have a great weekend.
Bye-bye.